Another major accomplishment that happened just about 5 days ago is the Hyabusa mission from Japan. It has been orbiting a small asteroid since last June, and well, this is just a diagram of where everything is. So here's the Earth's orbit. This was the spacecraft being launched, comes back past the Earth, gets a gravity assist, and ultimately rendezvous with this asteroid, which is a near-Earth asteroid in the sense that when the orbit is closest to the sun, it's not very far from the distance of the Earth from the sun. So periodically it will come relatively close. And the name of the asteroid is Ryugu. And so here's what the asteroid looked like. It's about a kilometer across, so 0.6 of a mile, thereabouts. And it's roughly diamond-shaped. It also is very, very rubbly. There's a view compared to Paris. I need to work on getting this done for Denver. Kim, I've got a new project for you. So the real goal of this mission is to collect a sample of this asteroid and bring it back to the Earth. And this is just an artist's conception of how this happens. The spacecraft settles down to the surface. It's got a sample boom. The boom, sort of a funnel on the end of it, contacts the surface. There's essentially a little pellet gun inside that fires little bullets at about 200 meters per second. So 2 times the length of a football field per second. That smashes into the surface, hopefully sprays material back into the sample horn, and they've got 3 sample canisters that they can swap out. So they have the capability of trying this 3 times. And so this is the design of the mission. They've spent many months surveying the asteroid and chose this location for the first landing attempt. And it's very clever what they've done. They have the small supply of little reflecting spheres with sort of facets on them. Those are target markers. They drop one down to land on the surface near a location that they would like to set the spacecraft down and collect a sample. And when you're in the geometry where, compared to the mothership, the spacecraft, the sun is over its shoulder or behind it, you get a very bright looking surface because all the shadows go away when you're in that kind of a geometry. And the sample marker actually lights up really bright. And so that gives them a target that their onboard cameras can see as they're settling to the surface. And here was just from multiple kilometers away in that kind of geometry. So the sun is toward the back of the room, and that bright spot is the sample, or the target marker that they dropped last fall. And so this is a closer up view of their target area. Here's the spacecraft for scale. It's about 18 feet across. And the problem they found, they designed this under the assumption the asteroid would be sort of powdery and a relatively smooth surface. And instead, everywhere they look, there's boulders. It's essentially a rubble pile. And you can see some of these boulders are the size of the spacecraft. And when they're settling down onto the surface, there's maybe that much clearance between the solar panels and the surface. And so they searched for a long time to try and find an area near the target marker that was smooth enough and didn't have big boulders nearby that they could land in. And so this is sort of a 3-dimensional model of that area. So the green spot marks their target, and you see the target marker here. So as they're coming in, they maintain that geometry with the sun behind them. The imager on board locks onto the target marker, and they're able to use that to navigate and just slowly come down to the surface. And as they were coming in, here's nearly the target area, and you see this bright spot. That's where the shadows are all going away, and that dark spot is the shadow of the spacecraft itself. So you see the spacecraft. I mean, you see it's sort of a selfie, I guess. And as they get closer, you see more and more of the spacecraft. And then this was right after they touched down. So they did succeed in touching down, and the little bullet fired, and they believe they got sampled, but it was only on the surface for a matter of a second or two, and then it hightails it back away from the asteroid. And this was a view from the spacecraft. Here's its shadow. And this area that's dark, they think, is where the surface was disturbed by the rockets used to, the thrusters to move it away from the surface. And so this was the target area that they wanted to hit. So they actually did a really good job. And right there is, right there is the target marker. So that's where they are. That was on the 22nd of February. They're currently orbiting a couple kilometers, actually a couple tens of kilometers, like 20 kilometers from the asteroid. And they're going to pick another location that within the next couple of months. They expect to try and collect another sample. And then once that second sample is in hand, they've actually got a much larger impactor that weighs, it's over 100 kilograms that they're going to shoot at the surface and create a crater. And then once they've done that, they're going to attempt to land inside the crater to collect a sample that would be normally underneath the surface. And so that's potentially a way to collect an somewhat internal sample, or at least one that hasn't been exposed to the sun in a long, long time. And then once they've done that, late this year, they will seal the samples up into a return capsule. They'll launch themselves or adjust their orbit so that they get back to the Earth, and I think it's then in late 2020 the sample canister is returned to the Earth, and hopefully we have a few tens of grams of samples of this asteroid.